Hello, this is my crystal. There is no crystal yet, only a solution that is clear and does not appear to have any suspended particles. More updates to come later on that. Our experiment to create this crystal required 4 parts, indicated here. First off, we dissolved 1.002 grams of aluminum foil and 50 milliliters of 4 molarity potassium hydroxide. Initially there were white fizzy bubbles and white gas was emitted. The solution was fully dissolved after approximately 5 minutes, creating a deep gray liquid with some solid, thick, suspended impurities. Second, we vacuum filtered the solution twice until it was pale gray, then added 10 milliliters of 9 molarity sulfuric acid, stirring as the aluminum hydroxide immediately began to precipitate into white icy solid clouds. Third, we placed the solution in its beaker on a hot plate for over 15 minutes, raising the temperature from 130 to 230 degrees Celsius and adding another 15 milliliters of acid. After this time, the top white cloudy film and suspended particles were fully dissolved. Finally, we created an ice bath in a large beaker and burrowed the beaker within the solution until the precipitate formed as a white mold-like mass, which grew on the bottom of the beaker. After 5 minutes, the bottom of the beaker was fully populated with this dense white cloudy mass. We vacuum filtered the solution to isolate the alum, washed it 3 times with 5 milliliters of 50% ethanol mixture, and added a previously calculated saturation mass of 5.147 grams to a container of 40 milliliters of water. The final solution was filtered into the vial indicated before. To create a crystal out of sodium chloride, as with the alum crystals, sodium chloride is more soluble at higher temperatures. Therefore, to create sodium chloride crystals, I would recommend creating a supersaturated solution by boiling a pot of distilled water and adding table salt until no more would dissolve. This would, the distilled water will minimize impurities, and if you add salt so that no more will dissolve, it will create a saturated solution. The distilled water, when the water cools, a greater amount of salt will remain dissolved than would if we had just added table salt at room temperature initially. Filter the solution through a coffee filter and add to a petri dish or saucer. Crystals will form at the bottom. If you select the best one of these crystals, tie a nylon string around it and suspend it in a separate supersaturated solution in a clean glass jar. The internet says it will grow to be very large. TheScienceCompany.com provides a list of various salts and additives which can be used to create crystals of specific colors and shape. For example, potassium permanganate will produce a dark purple rhombic crystal, while ferrous sulfate will be pale blue-green and have a monoclinic structure. According to Encyclopedia Britannica, a rhombic crystal structure is one in which all of the axes are equal in length, but there are no 90-degree angles. A monoclinic crystal structure has no axes of equal length, but 2 axes are perpendicular to each other. Also, fun fact, you can soak a piece of cardboard in water saturated with sodium chloride, leave it out in a sunny location so that the water dissolves, and crystals will start to form very quickly. This is according to thoughtco.com. Thank you for watching. This has been an episode of Crystals with Morgan.